All right, thank you for joining us. And I just want to talk a little bit about what you're looking at on the screen for a minute. The renewal invoices went out this week. So this is just a reminder that they are due by January 1st. Also, our conference, the 56th annual conference, is coming up May 7th through 9th in Charlotte.
Let's see, it was freaking super close. Yeah.
I'm going to be muting people, so don't be offended if I mute you, just so that we don't have any background noise while we're trying to listen to the presentation today. Going back to the conference, we have sponsorships opening up in the next week or two, and we will also have exhibitor and attendee registration opening up in the next month. So look to that. If you have not downloaded our app yet, I encourage you to take out your cell phone now and aim your camera at either the left or the right QR code, depending on your platform. And please download the app, and we would like you to engage on it. There are forums, there's newsfeed, there's direct messaging. There's a lot of great stuff there. Upcoming things this month in person, there is a Mid-Atlantic chapter event, a mock trial on November 14th. Virtually, we have our AC 478 roundtable coming up on the 21st. And then also next month, I don't have the exact date yet, but we will be advertising that soon. We are going to be doing our first virtual contractor and erector roundtable. So we encourage you to watch for that and to attend. So now I'm going to turn it over to, well, actually, I'm going to admit him first. Robert Tiffin, as he's joining us, and he is going to be introducing our presenter, Craig Shaffer.
Perfect. Can you hear me all right, Sasha?
Yes, there you are.
Perfect. All right. So good afternoon, everybody, and thank you for joining.
No, you're good. You're totally good. Thank you, though.
Our November webinar. So there's 2 points to this. One, obviously, safety is a key for us. Secondly, this webinar is being offered by the national organization to bring value back to you as the members to make relevant topics. So when you are listening today, and if you'd like to have a suggested topic, by all means, reach in. But without further ado, I'd like to introduce our guest speaker for today. This is Craig Shaffer. Craig is a certified safety professional and the owner of SafetyWorks Incorporated out of the Harrisburg, Pennsylvania area. He has spent 30 plus years in applied safety management, training, and OSHA compliance consulting with an emphasis in the construction industry.
Robert just went mute.
Robert, are you still there with us? We can't hear you.
Yeah. Did you hear any of that?
Yeah. And then I don't know what happened.
I said, Craig, over to you, and then
Go. There we go. Okay.
Perfect. Thank you.
Life is good. Am I still broadcasting?
You are. You're good.
All right. Life is good. Well, welcome, everybody. I appreciate you tuning in. Thank you, Robert. Thank you, Sasha, for the introduction. I appreciate everybody joining today. I guess I'll kind of jump right in. This subject here, today we're going to talk a little bit about a basic crane lift plans. I can't say it's anything, too crazy, critical lifts or anything like that, although I am going to bring up some points about critical lifts a little bit later. But just basically talking about the purpose of a lift plan, its components, and some other things. I do have that. You're going to see me zooming in here in just a minute. I do have basically a template of what I'm going to be going over. I think, if I remember right, member resources section.
Hello.
The MBCEA.
Sorry, I was just introducing the keynote.
Yeah, the member services or member resources section of MBCEA website, and I imagine the app as well. You will find this. If you're struggling to find it, you can always shoot me an email. I'm happy to attach it. It's It's something that if you already have a lift plan, great. If you don't, this kind of give you a little bit of a footprint or a roadmap into putting one together. So first things first, as we get rolling here, what's the purpose of a lift plan? Pretty simply. I mean, this is a critical task. Anytime we bring a crane onto a site, for my aspect as a safety director and safety director part of what I do, I mean, it's a critical operation, critical task, and planning certainly needs to be done. Just like an excavation or a trench, like fall protection and other things, we have critical tasks. It's important we plan them. I guess it was Louis Pasteur was the scientist credited with the quote that chance favors the prepared mind. So I don't like to take too many chances when we're dealing with cranes. Nobody does. So if we, the whole purpose of this lift plan, we think about what we're doing. We get our thoughts together. We know what we're lifting, how much it weighs, the rigging we're going to use, the hitches we're going to use, our rigging game plan, select the right equipment, crane, identify site exposures, identify the right personnel. We put all this stuff together into a plan, and I believe chance is on our side. So with that being said, regardless of whether your client requires a lift plan or not, I think they're very important to have. Like I said, even if our client doesn't require them, we have a lot to lose if we don't go through the thought process. One of the things, that I think I'm actually going to zoom in here a little bit on this, that it's come up in some discussions leading up to this is, before you get started talking with your client, just to get their perspective of what they're expecting. Some clients don't expect anything, or they're not asking for anything. And some clients, on the opposite end of the spectrum, want an awful lot. Some folks like the Army Corps of Engineers, maybe the Mine Safety and Health, MSHA folks. You could be working at a refinery, on or near an airport, hospital, places where they very much, due to the exposures around them, want a specific lift plan. And while this basic lift plan that you see here and that we're going to go through covers a lot of material, some of their lift plans, they may want their own lift plan filled out instead of this one, or they may ask that you submit some additional information along with your lift plan. So it's good to know that information up front as we go through this template right here. And as you're filling one out, for your projects, it's just one of those things you don't want to go through the whole thing and then find out they have their own form they want you to fill out, or there's additional information that delays your lift date and things like that. I know, personally, when I, sometimes when I'm involved in pulling together a lift plan, but a lot of times I'm involved in reviewing them. They've been submitted by a subcontractor lifting anything, from steel and metal building components to HVAC units to all kinds of different things. I usually ask for these about 2 weeks in advance, gives me a chance to go through it, gives them a chance to provide any information I need. I would say at least 3/4 of the plans that I review, I still need additional information. A lot of times they don't add, or they don't include certifications for riggers, for signal persons, crane operators, things like that. And it gets us a chance to get all our ducks in a row. That's what I ask for 2 weeks in advance. What I usually get is like 2 days or 2 hours in advance. And that just, it makes things a little rough. We don't get these things in on time. It really either delays our start. If you're working with the Army Corps of Engineers or perhaps MSHA, they may delay your start, and you're certainly at risk of being put at additional expense. And on the other side of the coin, we're not on one of those sites. Now we're taking risks that we don't have some of the information we really need to have. Now, do we go ahead without that information and take risks, or do we hold off in the lift? So those are just choices we're trying to address. Trying to not have to make those kind of choices by getting our plan in on time. So I mentioned about the components, the basic components of the lift plan here. And by the way, as I get started here, I asked Sasha if there's questions. I'm going to kind of periodically glance over at the chat window here, but I know she's going to keep an eye on it. And if you folks have questions as we go or comments, by all means, speak up. Said to Sasha, interrupt me at any time with questions. Try to answer them as we go. But with this basic rigging plan here, the first section I have is general. It's just a little bit of information about our company, about the lift date, and what we're doing. So, there's a spot right here where you have company and contact name. That's whoever's using the crane. It's the erecting company. The erecting company may also own the crane. They may be renting the crane. We'll get into the crane company a little bit later, but this is basically the folks who are using the crane. Not only their company name, but contact person and that information and their contact name or email address there as well. Project address, where's their project, the street address of it, so we can just identify what project this is for. The planned lift start date is always important to put on there as well. And again, the sooner we get this in ahead of the lift start date, the better off we are in case there's problems or more information they need. Scope of lift, and again, this is a Word document that's available in the member resources segment. So, when you can type in here and you can erase where it says describe objects being lifted or what the crane's used for, you can delete that and just put in there. Okay, this is for setting structural steel and decking. It's and miscellaneous metals. I was looking at a couple crane plans here before got started today, and I remember one here recently. It was for a gamma knife that was used at a hospital. It was a little bit something different, but just describes the scope of the lift. What all is being lifted, the equipment's going to be used, and things like that. Sets the overview of what's going on. And the other item that I had here in general is whether or not there's state or local jurisdictional requirements. I live here in South Central Pennsylvania. For the most part, not too many of those here, but I mentioned I know Dave Lombach with Kaiser Martin. I mean, they run into some folks that might be the Army Corps of Engineers. It might be MSHA, and sometimes they run into situations where there is either permit or notifications or additional information they're required for that. So I know some cities get into permitting. I know some jurisdictions, state. I know down the road, down in Maryland, is not too far from me. Down in Maryland, if you're doing a special lift, if you're doing a tandem lift or more than one crane's making the lift, or if you're setting up, tearing down, or jumping a tower crane, they require a 48-hour notification to their, I call it Department of Labor, but I forget the name of their agency at the state level that there's a requirement for. So again, depending where you are in the country, it's just something to remind you to check in. Are there any permits or notifications you need to make ahead of time? And again, depending where you are and what you're doing and who you're doing it for, you may have to or you may not. So that's the first one, just some general information. I move on to the next part of this plan, and it's a little bit about the load and rigging. I talk a little bit about the load and rigging plan here, and then we'll get into the site itself and the exposures that might be on the site and kind of things that go into helping us choose the right crane for the job. And then we'll talk a little bit about the crane specs, the size of crane, some other important information about the crane. We'll talk about the lift, lift capacities of the crane, and then we'll get into personnel. So those are kind of the main parts of this. But starting off with the load and the rigging plan here, you notice the first item I have here is load details, and it's just a little bit of information about what's being lifted. Again, our crane may be on site to lift one or two objects. It may be for a number of objects, steel columns, steel beams, decking, things of that nature. Again, we're kind of at the mercy of who's requesting this rigging plan. Personally, when I look at this, I'm looking, okay, I would expect if we're lifting components for metal building, for each object, provide its size and weight. I'm, basically looking at, okay, we'll be lifting, columns, heaviest one is going to be X number of pounds. A lot of times in the sketches that accompany the rigging plans and these lift plans kind of shows me what some of the lengths are. So, I usually look, I know personally it helps me an awful lot. I'm not sure if I have a picture of this over here or not. Maybe I thought I did, maybe I don't, but that folks will submit diagrams, just basically showing the layout of the steel columns, the steel beams, the bar joists, things of that. It shows dimensions. It shows, where everything's going. And again, most of the time I can see sizes on there. But most of the time I'm just looking for the weights. You have, a dozen, maybe 2 dozen or maybe half a dozen different sizes of components, just including their weight, so I can see what's being lifted and where. Also identify any special attributes. Maybe for steel, this is less of an issue, but sometimes especially if your company owns a crane and you're not all the time lifting metal building components, your crane might be hired to lift, again, a pretty delicate piece of equipment or a very specialized piece of equipment that is either easily damaged or very difficult to replace. So it would be a critical component. A little later on, I'm going to talk about critical lifts. So one of the things that typically makes something a critical lift is you're lifting something that is in excess of 75% of the crane's capacity. I know some companies and some folks use 85%. I'm going to use 75% today in our discussion, but whatever you use. But sometimes a critical lift is also lifting an object that is just very hard to replace, or is very time, the time schedule to get a replacement is very long. But anyway, just identifying that in the load details, and sometimes flowable contents too. Again, a piece of equipment or machinery that maybe has something in it that can flow, that can kind of it can kind of cause a different distribution of the load as it's being lifted. Just little details like that make this load maybe something a little different than what a typical lift is. Personally, when I'm looking at a lift plan and when I'm reviewing these kind of things, this kind of information helps, and it helps to minimize the amount of back and forth that I need to have with folks, just to get an idea of what are we lifting here, what is its size or weight. For most things, a diagram for most things, steel components, things like that, we may not need a diagram of the actual object, again, of the site. It helps me to see what all is being shown. But I wanted to kind of zoom in on this. This was a special medical device. It's called a gamma knife. But I just wanted to show you here something like this. Again, for you folks that have cranes that may be rented out to lift objects that maybe have nothing to do with metal buildings or little to do with it. Something like this. And there's other specs that they submitted with this that showed where the lift point was. But it gave me an idea of what was being lifted. There's another spec that they submitted that showed where the lifting, the eye bolts went screwed in and the distance between them and things like that. So it just provided, again, a little bit of information for me to look at in terms of what all was going on. So when you're putting together a lift plan, again, especially where somebody's going to be reviewing it, you're basically telling them a story. And our story starts with a load, and then it kind of evolves into what we're rigging. But with something like that, now I don't have one this little presentation here. With that gamma knife here that I just showed you, they also had a diagram that showed where its center of gravity was. Now it was a little less of an issue because the lift points, the eye bolts were engineered. But again, where we have, I can remember back a number of years ago, it was a large 20-some thousand pound rooftop unit being lifted onto Hershey's Children's Hospital, but they had showed the lift, not only the diagram showing the size of the object, but it showed exactly where the center of gravity was and the specifications, how many inches from the left end the center of gravity was, how many inches up it was, showed exactly where the center of gravity was for lift planning purposes. So, again, with specialized objects, critical components, things like that, those load specs become very important. So that's a little bit about load details. You're just explaining what's being lifted. And again, not all of these things, depending on what you're lifted, some of this stuff is pertinent, some of it isn't. From one lift to the next or one job to the next, you can kind of sort out of this rigging plan what's important and what isn't, but most of the stuff is. You look at the next item I have here, rigging company, rigging gear provider, and signaling company. Personally, that's important to me. I want to know, a lot of these rigging plans that I get really require information from both the company using the crane and from the folks who are providing the crane. Sometimes it's the same company, sometimes it's not. A lot of the crane plans that I get just come from the crane company. And if they're not doing the rigging, or if they're not providing the gear, then I don't necessarily get everything I need. So this up front, it sets the stage for me. Who's doing the rigging, who's providing the gear, and who's doing the signaling? Because later on, when it gets to personnel, I'm going to want to, personnel is like one of the last sections of this plan we're going to talk about, but I want to see what their qualifications are, what their certs are. So we'll come back to this a little bit later, but you're just telling whoever's reviewing this plan at the beginning who's going to be doing this work. Then the next one, again, says rigging game plan. And this is where I'm basically asking folks, look, how are you going to rig this? If they're just rigging columns, beams, bar joists, decking, things like that, I probably don't need a sketch, or I wouldn't include a sketch. I'd give an explanation. Beams and columns will be set using, chokers, or beam clamps, and a 2-leg bridle. Decking we'll use chokers or baskets, or whatever you're going to lift with the with the decking. But that's pretty straightforward. But again, on something that's a little more complex, sketches might be needed. And something like this, and this is call this my chicken scratch diagram right here. But let's just say it was a fabricated deck panel or something like that. These are supposed to represent bar joists. I'm a pretty poor artist, but you get the idea of what I'm saying here. Something that helps me visualize if somebody was lifting something like this into place. It lets me visualize what they're talking about. This one over here to the left, that's just a simple beam. I wouldn't expect somebody to have to sketch that. But this one over here to the right side, and I guess I'll kind of zoom in on this here a little bit, shows me the deck, kind of gives me some dimensions there a little bit, kind of put the little crosshair there in the middle where we're anticipating the center of gravity is being, and it's basically showing four sling legs. I'm showing shackles making connections at the corners, shackles making connections at the top, and bull rings. And again, it's a pretty rudimentary sketch, but when I review this, I can see what they're looking at, and I can see, okay, we got a total of 8 shackles. We got 4 round slings. I got a bull ring, maybe more than one, depending on the situation. And it gives me a little bit of a distance between where our connections are, so that it helps me when I'm looking at this to determine what our angles are going to be. I'm just looking here. I guess my arrow is showing up here on your diagram here, but we're talking about our sling angles here. So on this next part here in the load, when we're talking about our rigging, one of the things we're going to indicate is not only the type. Maybe I'm using round slings, maybe I'm using a 4-leg bridle or whatever, but depending how long those legs are, it'll help me to determine what their sling angle is going to be, and then ultimately how much they can lift. So again, a little diagram like this helps an awful lot. And again, especially if you have folks reviewing your rigging plan and your lift plan, it helps them see it and hopefully generates less questions. Now, the next part of this, so that's the game plan. That's what my thought process is about how this is going to be rigged. Now, now I provide a little bit of the details. What slings are we going to use? Identify the slings that will be used. What types of slings? Are we going to use round slings? We using straps? We using wire rope or chain, or whatever we're going to use. What's their size? From a wire rope standpoint, is it 1/2 inch wire rope? Is it 5/8 inch, 3/4 inch? Whatever it's going to be. From round slings, what size round slings? Size 7, size 5. Again, those things are important. As far as sizes for straps, you're probably familiar with the type. The type or the size indicator on the strap. It might be something like EE2-902, indicating it's a 2-ply sling, 2-ply sling, web grade 9 and 2 inches wide, whatever. But it just gives an idea of what type and size of sling we're using, and that way we can look and determine what the working load limits are. It's important to put the length in there too, because when you go back to this drawing over here, it's important to know the length of sling. I know personally for me, that helps me determine what your working load limit's going to be based on your sling angle. So all those things are important when it comes to identifying your sling. I've had folks, a lot of folks, they'll do something like this. They'll submit with the rigging plan. They'll copy, here's the sling we're going to use. Here we got 1, 2, 3, 4, 5, 6, looks like a size 7 here that they're going to use. They're showing me basket. They've highlighted everything for me, which is wonderful. Sometimes I get pictures. This is a picture. This is the sling we're going to use. Provides a lot of good information. Most of the information that I need to know. And again, the same kind of information is important from your hardware as well. Shackles, round sling, shackles or eye bolts, hooks, things of that nature. Usually shackles are the big thing. Here they noted a 1 3/4 inch shackle. One of the things that I do look at, particularly with round slings, I'm going to go back to this here for a minute. There might be some of you folks that attended this was back in Nashville, back in 2023, but we did the rigging class down. We talked a little bit about round slings, and based on the size of your round sling, it has something called a minimum stock diameter. Whether you have one sling or two slings going into the shackle, that's just the diameter the shackle has to be to allow those, the yarns that are inside, the core yarns that are inside the sling to adjust properly. So one of the things I'll look at is, for example, for an E480, and over here, that's down in this area somewhere, but I can go into my charts and look and see, okay, for an EN 480 that's being used right here, what's the minimum stock diameter? Just so that not only are they using a shackle that is properly sized based on its working load limit, for that share of the load, but also that provides the appropriate minimum stock diameter. Interestingly, with these folks that submitted this plan to me, back to this Gamma knife for a minute, they submitted a great plan. They did a really nice job with it. There was only one thing that I picked up on, and it was mine, quite honestly. They provided the shackle size for this, and it was the correct shackle size for capacity. But in all actuality, they needed one size larger to provide the minimum stock diameter. So again, I think that's important too, especially if you use round slings a lot. I know a lot of people do, but that kind of gets into hardware. Identify your rigging hardware that will be used, the types, the sizes, and working load limits. And again, providing these specs is really nice. It allows somebody like me or whoever's reviewing your plan to take a look at it. Just make sure what you provide them is the rigging you use. A couple times I see that we get this kind of information, and then I go out on the site, and maybe the information they provided me was from Crosby, but I go out on the job site and they are not using Crosby shackles or anything else. So it's just important to make sure it's specific to the manufacturer. So those are just some things involving load and rigging plan. And again, just some of the kind of most important details. And again, you can certainly add to any of this plan as you go along. Some of you folks I know are pretty involved in putting rigging plans together, and again, may have a rigging plan that goes well beyond this, but that's the load and the rigging part of it. The next part of it comes to the site and site exposures. This was a job site I was on a few years ago. Quite honestly, I was there with a general contractor, and so there's a lot of things going on. This was a school project, but one of the things, obviously looking straight down the roadway here is we're rigging, we're doing some steel work here and swinging, but we do have power line exposures, and talking to those folks, Shaffer, we're not swinging over that way. We're swinging over here to the building, and I get it, but there's some things that we need to do, even if we're staying at least 20 feet away from these lines, or maybe even 10 feet. I'll explain that more here in a minute. There are still things called encroachment precautions that we most likely will have to take. So I'll come back to this in a minute, but before I get to it, let me talk about site exposures. We're going to talk about power lines, and then I'm going to come up here to the top and talk about, are there other site exposures, some other things that we'll talk about. But let me hit power lines here first. And the first thing I ask is, on this job site, are there any power lines within 100 feet of the job site? Sometimes I'll even say 150 feet. I just want to know what we're dealing with. And where they are, because again, our crane may be set up 70 feet away from the power lines. And, are there any power line exposures? I will see no. But yet, if I go out to the job site and the power lines are 70 feet away, well, Shaffer, we're not swinging that way. We're 70 feet away. We're fine. We just got to stay 20 feet. We're good. And that's fine. But, in a situation like that, where you're going to see actually this little part here in gray where it says this is our power lines within 20 feet of the crane's maximum radius. This is defined as 360 degrees around the crane and its rigging or load when operating at its maximum possible radius, not just the lift radius. So if the crane at maximum radius could get within 20 feet of those lines, we have to do one of these things down below. So that's why I'm asking, look, is there anything within 100 feet of the job site? Just so I know where we kind of fall into play down here. I noticed here on my presentation, I had little check boxes here. They didn't show up when I imported it onto this presentation, but the Word document does have little check boxes here. But if, are there lines within 100 feet of the job site? If the answer is yes, look, if they are really high voltage, if they're over 350,000 volts, I'm saying, look, contact the power line owner for clearance requirements and what they want you to do. There's certainly high voltages there. If we're less than if we're 350,000 volts or less, then continue on. Here's what we got to do. Now I'm asking you, are the power lines within 20 feet of our crane's maximum radius? And again, it's not the lift radius, it's the maximum possible radius. All right. Now I got a little star, a little asterisk here behind 20 feet, and that's down here. Turns out if our power lines are, and listen, what I'm telling you here is, I should say this, is federal OSHA. I mean, I'm here in Pennsylvania. We're a federal OSHA state. I don't, I know this would apply down in Maryland stuff, but I don't know all the different, state requirements. So for some of you folks that are in state OSHA, you may have some different requirements. I'd have to look and see what those are. But with federal OSHA, here's the deal. If we call or the crane operator calls the power line owner and confirms with them that the voltage is 50,000 volts or less, there's a table. I think it's called it's either table 1 or table A. Table A. I'm cheating off my cheat sheet over here. Table A is what it's called, which once we have verified it is below 50,000 or below, we can reduce that clearance to 10 feet. So that's why that little asterisk is there. Lines to 350,000 volts or less, are there any within 20 feet of the crane's radius? If so, we got to do one of these 4 things. If we or the crane operators call the power company and say, oh, it's 7,200 volts, it's 13,200 volts. Okay, they've confirmed that it's 50,000 volts or less, then this requirement up here drops to 10 feet. Okay, so that's what that's all about. But anyway, if the answer is yes to this, like I said, we got 4 options. We can have the lines de-energized and grounded. We're not doing that. That's got to be the power line owner. And again, I can't speak for anybody else, but I know here in Pennsylvania, at least where I live, that ain't happening tomorrow, and it ain't happening next week. That's it's something we got to plan in advance with those folks. They are not in a hurry to get to that. I can't say they're not in a hurry, but it's a while till they get there. That's preferable. I mean, if they're de-energized and grounded, there's no clearance requirements then. The next thing, the lines can possibly be relocated. I've had that happen. Again, at least here, it doesn't happen soon. It's something that takes a while to plan. But where they have relocated the lines, or sometimes they'll put an outrigger on a power line to move the lines farther away to gain us those extra couple feet we needed. So that's an option. Of course, that's obviously done. The relocating would be done by a power line owner as well. The next one, lines insulated. Again, where I'm at, it's not often that the power line owner will put a dielectric or insulative covering over the power lines. Again, maybe they will where you're at, which is great. A lot of times that will reduce clearance. If so, that's great. And then you can put what the new clearance is. But those are 3 options that we have that are preferred. Obviously, de-energized is the best if we can do a scheduled outage. But listen, you look at this 4th option. It says, we'll use encroachment precautions as follows. So I look at this and I'm looking at where, I'm looking at the diagram that shows where the crane's going to be set up. And yes, at maximum radius, we could get within 20 feet or 10 feet of those power lines. However, where we are picking up our steel, where we are swinging it, it is not coming within 20 feet or 10 feet. That's where encroachment precautions come into play. They're pretty quick, pretty simple and easy. And these are what we got to do. I rarely see these, but this is what we got to do. First of all, we got to maintain that minimum 20 feet or 10 feet to the power lines. Second thing, warning line to mark the 20-foot boundary visible to the operator. Now, listen, it can be flagging, it could be cones. I've seen like markers, like high vis markers, things like that, but just something that sticks out to the crane operator and to the people rigging, signaling, and that are in the area, just that the crane cannot go beyond this point. So even, Shaffer, we're 70 feet away, don't worry about it. You still got to put those up. It's not hard. It doesn't take long, but that visual barrier still has to be there. And that's important. Next, pre-lift meeting to review the power line locations and precautions. So as part of the pre-lift meeting, it's kind of, hey, don't forget, we got power lines over here. We got the cones, we got the high vis markers set up. Just a reminder, you folks that are signaling, don't swing past that. Crane operator knows not to swing past that. All stop before we get to that point. Tag lines, if used, will be non-conductive. So non-conductive tag lines or use of insulating links for the tag lines if we're going to be in this encroachment range. And finally, enhanced precautions if the operator can't see the warning line. This involves the use of spotters and another safety precaution. There's a number of those. If you need them, you're welcome to email me or call me or whatever. But there's range warning devices. I know I've had a crane one time. We used an insulating link, which in addition to the spotter. So those are both options that were able to be used. But again, I mean, this is probably one of the biggest, in addition to the surface on which a crane sets, probably one of the biggest exposures we have, and that can really ruin an otherwise good and productive day, is just knowing where these power line exposures are and what we need to do. I often run into cranes just like this one, where here's a situation they were picking in the background. So at no point did they need to swing within 20 feet of those lines. I mean, they're pretty close to it right now. In actuality, they did call, that was less, I forget what the voltage was. It was less than 50,000. So it was actually 10 feet was their required clearance. But they need to have cones, set up down kind of parallel along here just to mark their no swing boundary. Okay. Other site exposures. So power lines are a biggie, but listen, are there other things? And this is where a general contractor is helpful as well. As a matter of fact, there are a couple things. When we deal with cranes, there are two things specifically that a general contractor is responsible to do. The first thing has to do with these items right here. Identifying and notifying the crane operator, I guess more so the second item here, the ground underground voids, vaults, tanks, things like that. If the general contractor is aware of any of these things, underground voids, vaults, tanks, pipes, utilities, they need to communicate that to the crane people, obviously, so we don't want to set our crane up over, especially outriggers. We don't want over top of that. So if they have been informed of this through maybe a municipality or by the client itself, they're responsible for forwarding that information to the crane operator. The other requirement GCs have is to provide a safe location for the crane to set up, and I'll talk about that here in a minute. But other things, just to identify in our plan, whether there's excavations that we need to avoid when we set up the crane. Is there an occupied or partially occupied building where an evacuation or partial evacuation may be necessary for parts of the lift or the whole lift? Exposure to public vehicles or public traffic where a traffic control plan may be needed. Is there an airport, helipad, or railroad nearby requiring notifications and coordinations there? Obstacles or obstructions to avoid, machinery, equipment, building components, things of that nature, or anything else we need to know. Again, this is a lift plan, but this kind of information is somewhat drives, or not somewhat, it does. It drives some of the deciding factors about where the crane can and cannot set up. Because the next thing that we have here in our site exposures part of the plan is where's the crane setting up? consider lift parameters. In other words, all right, here's what we got to lift. Here's how far in off the roof or how far in on the pad that we have to lift it. How much it weighs. That, lift charts all kind of determine, what size of a crane we're going to need. But now, we also have to consider, okay, yeah, we'd be able to use a crane that maybe has we'd like to set up where it's an 80-foot radius. But you know what? This area where it's 80-foot radius has some pipes running underground. We can't set up there. We got to set up at another place that's now 100 feet radius or 120 feet. So again, some of these things up above may drive where this crane has to set up. So consider our sketch, considering lift parameters, the crane limitations, and identified site exposures. Personally, I like to see a sketch because it just kind of, again, visualizes. Here's a pretty nice one here. Just showing here's the outline of the building, excuse me, or the pad. In this case here, they're setting what appears to be an HVAC unit onto a roof, but it shows me where the crane's at, and they've added some additional information. It's kind of hard to see here. I lose a little bit of the definition of this picture here, but anyway, you see exactly they're kind of giving me radius here, giving me some other important specifications for this lift. What we're kind of getting into here next is the lift plan. So not only is this telling me a little bit about the crane, the base that they're expecting, lift radius, it tells me crane's capacity for what they're being set up as, but a little bit of information about the crane, the block, the rigging weight, the total rigging weight, the load capacity. So in other words, we're going to get what our total load is between the rigging, the crane items, and the load, and we're going to compare that to what the crane's capacity is. Now that's really what part of this is right here. This gets into the crane information. But, reason I really showed you this picture is it just kind of gives me an idea of where the crane is setting up, where it is reaching to, so I can kind of see where we're planning. Sometimes it's just one place the crane's setting up. Sometimes it's multiple places. And again, providing that information to whoever's reviewing your crane plan, very important. Now, looking over here to our next segment. So this last segment was a little bit about the site and site exposures. This next one is about the crane. And now, ultimately, we are getting down here where it says lift percentage of crane capacity. Now, a lot of these lift plans have this in. I really like when they provide that. They've done the math for me. This is a number I'm looking at. Quite honestly, I prefer to see it below 75, which this one barely is. You get over 75, you have a critical lift. And a lot of folks, including myself, want a critical lift plan at that point. So, which involves some more documentation. But let's look at crane information here a minute. First of all, who's the crane company and what's the contact name and information? So that's the first thing, pretty easy. What type of crane are you bringing onto site? I know for me, it's most of the time it's a mobile telescoping crane, but sometimes it's not. Sometimes it's a different crane. Make, model, and capacity. I asked that they attach to documentation of their current annual inspection. Just something that I review, that I match that crane inspection documentation with the crane that they have just identified in the previous section right here. Maximum wind speed. I don't want this to be personally, I don't want this to be a subject of debate on the job site. This should be known ahead of time. The crane manufacturer sets what their maximum wind speed is. Some cranes say, look, you are good up to this amount of wind speed. And others say, look, we'll maybe give graduated up to this wind speed. You're good up to the next wind speed. You have to reduce your lift capacity by X number of percent. And then you can't go beyond this wind speed. So whatever those parameters are, I want them known ahead of time so that not only us, but the general contractor, everybody's on the same page. I'm quite sure everybody here is probably familiar with the years ago that when they were building the Milwaukee Brewers Stadium, Miller Park there, the big blue crane collapse. So wind speed was a key factor in that. And, these are just the things that we're trying to prevent is poor decision making. When this is known up front, we're all understanding it. Surface expectations. This gives my crane folks a chance to explain to the general contractor what surface they need to set the crane on. You know, a lot of times it's pretty straightforward, you know, improved base or something that can hold so many pounds per square foot, or something with gravel base, whatever your crane manufacturer specifies, but you're communicating this up front. Because again, if, you know, we're working on a site where we got an awful lot of mud and you know, it's kind of sloppy, soft, things like that, it gives them a chance to coordinate with the folks that are the site contractor and get improvements made. They are responsible providing a surface that is acceptable for our crane to set up on. And by the way, for you to lay your steel down on as well. That certainly applies also. Mat and cribbing type and size. You know, this is just where I want to know that some thought was put into this. You know, a lot of times I get something that's this. I know these are nice computer programs that print this out, and I really like them. Tells me exactly what I need to know. And quite honestly, if I'm working with a general contractor, this tells my superintendent what we should see. This lays out the specs of what this material should be. So down here, it's you know, it's oak material. They give the specs on the, you know, the height, the width, the length, and all that kind of stuff there. But then I'm looking down through here. This is the mathematic part that, you know, here's the maximum allowed. Here's where we're at. We're good to go. Here's the maximum allowed. Here's where we're at. We're good to go. So I can see this. Now, it also shows my superintendent, this is what it should look like, versus, you know, 3 4x4s. I mean, I'm kind of being a little ridiculous here, but, you know, not all the times is it nice, neat, and tidy like this. And sometimes I get some sloppy cribbing that is not what was advertised in their lift plan. So I do want to see you know, this kind of information. So again, for the crane company, again, this is the stuff that's kind of gets spit out in their computer programs, but it's really nice for somebody who's reviewing it to make sure that your crane will be able to rest on a surface. And again, it's kind of, you know, providing our ground bearing pressure below the mat. Right there, it's telling you how many pounds per square foot, and they can compare that with what the bearing capacity of the soil or the surface is. So it's good information, important information for them to have. And again, I can't speak for the Army Corps of Engineers, but I can imagine they look at stuff like that. The next thing up here in our crane information is just the crane gear weights. You saw this a little bit in this crane plan that was listed up here. I'll zoom in just for a second, but you saw the block 385 pounds. The rigging was 100 pounds, and there you go. But this just gives us a chance to kind of add in any weight we need to add. So from the crane company standpoint, here's our total crane gear weight. Down below, we're going to identify our load weight. How much is the weight of the load? You know, listen, sometimes I saw in the weather, there's parts of the country already that are getting hit pretty good with snow. I mean, so sometimes especially we're lifting big items, ice, water, we need to account for that weight, you know, because again, something with a large amount of surface area, it's an awful lot of weight. Sometimes we have specs that says this special object we're lifting for a client weighs this much, but that special object's got stuff in it. It's got contents in it that we might have to add weight for. So this is where we're figuring we got our rigging, not a rigging weight, but our crane gear weight up here. And down here we got our load weight, add that to the gear weight, and that's our total lift weight. So you saw on my example up here, you know, here was the rigging, the crane gear weight was 485. What they were lifting was 1,300. The total lift weight, 1,785 was what they came up with. Now, so this just kind of lays out in a nice, easy to follow chart here, or table, whatever you want to call it, what we're providing. And I have, you know, lift 1, lift 2. If we're lifting different objects, it allows you to provide for each one of those. Down here's where they're telling me about the crane. What's the lift radius? What's the boom length? What's the boom angle? And then what's the crane capacity at that maximum radius? Again, this lines it all right out for me. Up here, they told me a little bit about, here's the lift radius, and here's the crane capacity at that lift radius. Up here's the boom and what the angle was, and it spits out, again, the computer did it, 2,400 pounds. 74% capacity. So they took what their total load was, divided it by the total capacity, 74%. Again, we try to stay 75 or below with that. But they also, I like when they provide the load charts for me. This is the load chart that went with the crane that they identified in that plan. And they highlighted the part here for me, the boom section, percentages, the boom angle they highlighted, and came right over here and showed me exactly where the 2,400 pounds is. Again, depending who's looking at your who's looking at your lift plan, it could be the trust but verify. Again, somebody like the Army Corps of Engineers. Okay, that's great, Craig. You provided all that. Please show me the load chart from the crane operator so I can verify that. And I always do, and I don't think I ever run into problems. But it's there, it's verified, and it's all proven. So that's what that segment is. I didn't talk about critical lift yet. I'll mention that in a second. But over 75% is probably going to require a critical lift. You may also check with your client. Theirs might be a different percentage. That's where my last part here, having to do with crane information, comes in. Do any of the following apply? Listen, these are just things that I have on my lift plan. And again, it can vary from one client to the next, but does any pick exceed 75% of capacity? Will the crane be used to lift personnel, personnel basket? Are we doing a tandem pick? Does the client have any special critical lift requirements? If we're checking any of those boxes, we're probably going to have to submit additional information, which, usually has to do with a verification of the load weight. It might be specs from the manufacturer, it might be scales, but something that actually verifies the load weight. And then, we're, and a lot of times in these critical lift plans too, we're identifying, pretty much the capacity of the crane, not only at one point, but from the pick point, which is where our start point, our pick point, to where our final resting point is, to make sure throughout that entire swing path, it does not exceed the crane's limitations. And so sometimes, critical lifts will get into some additional information there as well. Usually pretty picky on what the rigging is going to be used and things of that nature. So that's what that gets into. So again, it's just something to consider. Is this a critical lift? Most of the time I have folks that try to stay 75 or below in their percents here. The last part of this program or plan, whatever, is just some real quick the search crane operator. I'd like to have the names and qualifications relevant to the crane that's being used. Sometimes it's one crane operator. Sometimes they'll send me search for 4 or 5 people because they're not sure which one's going to be there. Just make sure that when we provide them the cert, that's appropriate for the crane they're going to be using and that it's current. It hasn't expired. So like a CCO or equivalent certification. Some states, I know here in Pennsylvania, the operator's got to be licensed. Make sure that's current. And some folks also include copies of these operators' CDL, DOT medical cert, and or sometimes even employer evaluations. Again, if you provide those, just please make sure that they're up to date, or they're current, I should say. With the rigging people, name of competent person who is overseeing this. Who's our person responsible for overseeing that this lift plan gets integrated and communicated to the rest of the crew? Also, who else is involved in rigging relevant to their work? What is needed? Some states here in Pennsylvania, what's qualified? Well, you have to be trained, and your employer has to deem you I should use the word qualified. In other words, you've demonstrated your ability to rig within the parameters of what you're being asked to do. I drive down the road a little bit and get into Maryland. They have something called Rigger 1, Rigger 2, and Master Rigger. And for picking and setting steel columns and beams and joists and things like that, most of the time Rigger 1 applies, but you get into some complex lifts. Now Rigger 2 and or a Master Rigger is required, especially if you're assembling cranes, tower cranes and things like that. So again, some states and some even local jurisdictions, cities, things like that, may have their own specifications. They they may permit a person to be trained from a third party source or in house, and some jurisdictions or some jobs may say, look, it's got to be from CCO or something. So again, knowing that ahead of time, so we meet those specifications or those contract requirements. And again, just make sure it's current. A lot of some certs do not have expiration dates. Some do. So just make sure it's current. And the same thing with signal persons, that they are qualified, relevant to the crane they will be signaling, whether it's a mobile lift, whether it's a tower crane, things of that nature. And again, relevant to the state, local, or city, the jurisdictional requirements, whether it can be third party, whether it can be in-house training or whatever you use, or does it have to be a certain cert that they're required. And again, it never hurts to put in your plan here, who's the safety contact, just in case there's questions or whatever. A lot of times that's the individual submitting this. I guess I look on this, that's the one thing I didn't think as I was putting some of this together, I really should have put in here is the name of the person submitting this plan. Maybe that's your safety contact, but you can add that in there in the end as well. The last item I have here is just a little check sheet of submittals. I didn't count them. It's probably about 10 or a dozen things here, but these are just things that we kind of promised we would submit along with this. And again, from my standpoint, when I review these, it just makes me feel, when I have these, it makes me feel much better about the lift plan. So first of all, if there's any jurisdictional permits or notifications, that I've included that with this plan, or at least that if I've notified them, that I've attached documentations of that communication. Load diagram and specs. These are all things we've spoken about here in today's webinar here. But again, the load diagram or specs, if it's something that's more complicated to pick, again, especially that shows center of gravity, things like beams and columns, you're probably not going to have that. Sketch of the rigging game plan, how you're going to rig it. Again, something simple. I'm not expecting them other than to say, we're going to use a choker. Something a little more complicated, a sketch or something helps. Sling and rigging hardware specs from the manufacturer of who we're going to use. Again, that helps me determine what working load limits are, and especially when I'm determining your working load limits based on the angles of your sling. As you folks know, your angles of your sling are going to impact how much we can lift. What's the stress on the slings and the rigging attached to it? That's important. A sketch or a diagram of the site exposures, any restricted areas, crane setup locations. And, most of the time, I'm not asking for every lift, but what's the heaviest lift as a percentage of crane capacity? Sometimes it's the heaviest object. Sometimes it's not. It's just a far reach, and that makes it a higher capacity, when it's compared to what the crane's capacity is for that radius. The crane's annual inspection and documentation, crane material cribbing calculations or specs, load charts for the crane, operator certs and licenses, rigger training qualifications, and signal training qualifications. So like I said, I get a lot of these that just come from the crane, and the crane folks do a great job, but then the folks that are using the crane forget that they got some responsibilities in this too, to provide information. So I kind of thought that I might have a little bit extra time, but I'm happy to stay on as long as anybody wants to. But for questions or comments, it was kind of a whirlwind tour, and there's limitations. Like I said, this is kind of a basic rigging plan, but I hope it's helpful. And it's many of you folks, I'm sure, have your rigging program. That may be more than this. Some of the stuff you might want to add to yours. You're welcome to do that. Some of you may not have a lift plan, and this is helpful to start yours, but whatever. I guess I'll open up here. Did you catch, I'm looking over here. I see, Joe, you have one here. Address OSHA citations for failure to designate a lift director. Is this only required for multiple crane lifts? Can employer designate a qualified person as a lift director based solely on extensive knowledge, training, and experience? So I guess what you're looking at there, Joe, is the assembly and disassembly director. I don't know if that's what you meant on that or not, but there's I'm not sure. Can
So Craig, for
oh,
clarification
beautiful.
on some of the NCCEO sites and some of the other websites, they have mentioned that as far back as 2013, OSHA has cited companies for failure to designate a lift director. So that kind of leads into the second question. Does ASME have, is that incorporated by that ANSI ASME B30? Is that incorporated by reference anywhere in OSHA? And does it have any, how can they cite you for failure to designate a lift director if it's only required for multiple crane lifts?
So this doesn't, if I'm understanding, Joe, this has nothing to do with assembly, disassembly. They're just talking about a lift director, period.
That's the way it reads. That always piqued my interest. I've told the guys in the field that the foreman is the lift director. It's got to be a qualified person under the ASME definitions, but I don't see anywhere that OSHA incorporates ASME by reference. So how does it hold any weight? How can OSHA fine you for that? I want
I,
to know what that standard is that they got away with that fine.
yeah, and listen, I get folks sometime too. Oh, I heard so and so got cited for something, and sometimes one of a couple things happen. It was either in a state plan state that required it. So the first question I would be, what state that I would have is what state was this in? So I'd have to look and see, do they have state specific requirements that would address it? And listen, I mean, if it was a federal OSHA state, I'm the same as you. I'm not aware of any that requires a lift director for that outside of assembly, disassembly. You know, that I guess that would be my second question. Were they assembling or disassembling a crane where you did need to have an AD director appointed for that? And then the third question is, you know, it is not out of the question that somebody was cited for that, but does not need to have it, and they fight that and win. That doesn't happen often, but I've had that. You know, where you're cited for something that was, you know, it was maybe in an ANSI standard or what was considered a best practice, but was not part of the scope of OSHA's regulations, and they deleted it. I mean, it was maybe an inspector's call or something. I had something like that involving. It had nothing to do with cranes. It had to do with where an extinguisher belongs near a refueling place. But what they were looking at was an NFPA document, and what I'm looking at is what their requirements were, the OSHA requirement was, which was different. And so they did delete the citation. So I don't know if that helps you at all, but those would have been the first 2 or 3 questions that I would have if somebody told me that.
Yeah, I'm just curious because I hear a lot of times GCs and construction managers reference standards that aren't hard and fast rules, that are great suggestions, but they're not necessarily, they quote it as though it's the Bible, and I don't believe, at least in New Jersey, that ASME has got any legal weight to it.
Yeah, and when they go to ASME for things, I'll have to look, Joe, and look at their standards. But you know, their standards, as you know, they don't update them very often. So even if they do reference ASME, it's probably from the 1970s. It's probably an old deal. I know ASME updates periodically, but that does not automatically transmit into an OSHA update at all. So I guess, quite honestly, I would put that back at our first part. You know, for you folks that run into things like this, is, you know, back to the client specific stuff. So are we going by OSHA here, or are you requiring something different? And maybe hammering that out with them a little ahead of time.
Sure, obviously Army Corps, that kind of stuff, they have their own versions of it, not using a retractable and a boom lift and other dumb stuff. But
right.
the second one that I put up there, I know we've talked about before, Craig, but just for the benefit of anybody that might be a construction manager listening, is the clarification on telehandlers, because there are letters of interpretation that I get it all the time, where somebody sees you hanging slings off the hook under the boom of a telehandler and they call it a crane, and it is not a crane. Can you elucidate on that?
Yeah, and I'm sorry, Joe. I'm just looking here real quick, and I was looking at other questions here. But we just had this conversation the other day. Somebody had asked about my email address, if you have questions or whatever. So I put that in the chat. I think it'll pop up in there, Craig at SafetyWorksInc.com. But with regards to extensible boom forklifts and cranes, let me see. Give me just a second. I'm going to see if I can pull up a picture that will be worth many words. Crane.
While you're doing that, Craig, but you do need to make sure, I know Joe knows this, but you just can't take any RTF and use the hook on it. You have to make sure the hook that's on it is approved by the manufacturer, et cetera. That's a big thing today. So you can't take your hook and drill a hole in the fork and be lifting stuff. It's got to be.
Yeah, we run into that where even when you have a fork mounted hook or something that was not built onto it, that you have to get a letter or demonstrate that it was approved by the manufacturer to use any kind of attachment like that. So yes.
There we go. Fellas, thank you. That granted me just enough time to find what I'm looking for. So yeah, the jib attachments, manufacturer approved. And by the way, so two things about manufacturers approved attachments for lifting. So the jib, again, like you guys just mentioned, it's approved by manufacturer. If you are not sure, the load chart on your forklift will indicate, if you flip it back to where they show jibs, most of the ones I see, it will list on there the serial numbers of the jib attachments that they will allow. And then you look at the data plate on the jib just to make sure it matches one of those. The other thing is some of your lifts on the back side of the forks, the carriage, or the boom, there's a shackle that you can use for lifting, or a lifting lug for that. And, so that we can rig from that. So with regards to that gets into a situation where you look at the load chart, and does the load chart show a picture of those forks still on your forklift, or does that load chart show the forks have been taken off? So if your lift has that lug or that shackle and it does not show the forks on there, you got to take the forks off for that load chart to be accurate. But in both of those cases, whether it is a manufacturer approved jib or we are using the shackle or the lug, whatever you want to call it, it does not render your rough terrain forklift a crane. Now, this picture, I rarely run into this, but this was one I run into a couple years ago that did qualify for a crane. And this has all kinds of attachments. Most of the time, this was a rough terrain forklift. But what happens, this attachment, it's kind of hard to see here, but if I zoom in a little bit, you see the hoisting mechanism. And this is what makes this a crane. So this is a jib that can raise and lower a load without using the boom. So they can place this, and this thing's slewed as well, to the side and everything. So this thing, once they got it up in the air and slewed to the side, they can use this hoist now to lower the hook. And this made this a crane. And now here's where I got to go back and I'm going to pull something else up here, because quite honestly, I can't remember it off the top of my head. When you get something like this, that's a crane. Depending on what the capacity of this is, there are certain parts of the crane standard that no longer apply, but there are some that still do. And I want to say like 2,000 pounds
is 2,000 pounds.
Yeah. Thank you, Joe. Yeah.
Yeah.
And I can't quite remember what was exempted and what wasn't, but.
And so they exempt things like if you're using like a sheetrock winch, boom on a truck, something like that, it is not covered in the standard. But if you tried to use that to connect steel to a building, you're going to get hit for it. So it's a little bit different. If you're using it to load sheetrock into the second story of a building, it's not a crane. But we have the Magni, and that is the other gray area, because that rotates. Everybody points to the standard, by means of whatever. But since there is no winch, that's what I want to clarify. It is not a crane until you put that winch on there.
Correct. And listen, for anybody, I have somewhere, I got it buried, but I know I got it. There is an OSHA interpretation that kind of lays that out a little bit. If anybody needs that, let me know, and I'll find it. I know I got it. I just got to find it. But that lays out, what we were just talking about, the difference between this and something that does not have the winch. And yeah, Joe, here we go. This is the slide I was looking for here. So for stuff like this, crane regs that still apply. These are the items that still apply, that have to do with the crane standard. So not all the crane standard regs apply, but these do for something like that. So yeah, I mean, still, it's logic. It's, I guess logical is the right word to use, but a lift plan for this, because I mean, you look at this. I mean, it is gonna. You got two things going on now. You have the capacity of this jib, the winch, but you also have capacity and stability of your forklift as dictated by the load chart. So yeah, I mean, lift plan would be great from my standpoint with something like this, that I can see that both things we are not overloading. We could be within our capacity for the jib, but not be within the capacity for the forklift.
Okay, Craig, thank you so much. We really appreciate you taking the time, providing this template for our members for these crane lift plans and reviewing their requirements. Thanks everybody for hanging in there after the hour. And we will have this recording on our website in the products and services, and we'll try to email it to all of you as well. Craig put his email address in the chat as well, craig@safetyworksinc.com. I also put the link to the member resources document section where this form is, and you're going to want to go to the project planning form section of the templates and documents inside the member resources to find it. So thank you again, everyone, for your participation, and Craig for the presentation.
Thanks, everybody. Thanks, Sasha.